In this video we're going to be having a look at one of the string functions known as Mem Copy, which stands for memory copy. Now this is a function that I use quite a lot. It's a really useful one, and it has a prototype in this form. Void star, which we're going to talk about shortly. Mem copy. Void star destination. Const. Void star source. Size t num. Right, so that's the prototype for the Mem Copy function. So let's have a look at a few of these things. First of all, something you might not have seen before is void star. This is a pointer to a void. Now what we've told you before is that a void is empty, it's nothing. That's where you don't pass an argument or it doesn't return anything. Well, actually, pointer to a void allows you to pass any data type to a function and have it treated as simply bytes or simply as a general type. Remembering that this function just copies memory, so all it has to do is copy bytes. It doesn't care whether they're chars or ints or floats or structures or whatever they are. The only thing it's interested in is copying bytes. So it basically allows you to have it treated as a general type. It can then be recast. Okay, so you can then cast it to another type if you want to. But it's just a sort of general type. The other one you might not have come across, so that's void star up here. The other one you might not have seen is const. That means in the context of a function argument list that this argument will not be modified by the function. Alright, so whereas this is the destination memory, and obviously it will be modified because that's where we're copying our data to, this is the source memory. So this is the data location from where we're copying our data. So in other words, don't modify the source memory, which is what we want to do, only modify the destination. So the source is const, meaning it's not going to be changed, while the destination is not const, which is how we normally declare variables and pointers, therefore it will be modified. The other one that might be new to you here is this size underscore t, which is an architecture dependent, and it really depends, but arch dependent long or int. It really, it's a little bit rough into which compiler and which architecture you're working for. For example, in a 32-bit computer that will be a 32-bit integer, and a 64-bit computer that will be a 64-bit integer, provided that's how it's been compiled. And so the final number then is, regardless of that fact we've got a size t there, is the number of bytes. And it's very important that you understand that it is the number of bytes and not the number of elements in the array. So number of bytes. So if you were copying to 16-bit integers, for example, you would not put 2 in here, you would put 4 because you are copying 4 bytes. Alright, so this is the prototype for Mem Copy, and basically you pass it the memory that you want to copy from, the memory you want to be copied into, and you tell it the number of bytes and it does it for you. It will also return the destination pointer. However, I very rarely ever use that in my actual programs. I normally just call this function without a return argument. Alright, so let's have a look at the way we can use memcpy. Now in its simplest form, let's say we had char x and y, and we said y is equal to 3, then if we were to write the statement x equals y, we've effectively copied memory. Right, so that's effectively what we're doing. We're copying memory. However, all we've done here is copy a scalar, one value. Okay, it doesn't have to be a scalar in terms of a numerical value, but we've just copied one value. We could do the same thing using Mem Copy. So, Mem Copy, remember the first argument is the destination. It's what catches out most people, including myself sometimes. So the destination would be x. Now we need to pass it a pointer to the memory location, right, noting the star there. So as we know, in order to reference the memory location that is the variable x, we need to use the ampersand x. We pass a pointer to the source, ampersand y, and we tell it the number of bytes. Now I'm going to hard code this as 1, but I'm going to show you later a better way of doing this. So this is equivalent to the line above. Right? We've taken the information that was in y equals 3, and we've copied it to x, and we've told it we're going to copy 1 byte. So far, alright, that's not so interesting. We can do that with one line. Okay, let's have a look at something a little bit more interesting. Let's say we have integers, which on our micro are going to be 16-bit, for example. And I'm going to call this one, let's call it D for destination, and I'm going to make that a 3-element array, and S of 3, our source, is equal to 0, 1, 2. So that's going to be an initialized array using the curly braces. Now, if I wanted to copy from my source array into the destination array, a lot of people might do something like this. Now, unfortunately, we still only have one copy of the data. We haven't actually copied anything. All we've done is change D, which is a pointer. Remember, with an array, the variable is just the pointer, but pointing to the beginning of that array. Let's change D to point to the memory location of the array S. Alright, so in memory, let's say we've got, so this is memory along here in RAM, and let's say that's what D points to, and we have no idea what's in D because we didn't initialize it, and this is what S points to, and we know that those values are 0, 1 and 2, and this is all the memory in between. We don't know what it is, we don't know where it is. Compiler sorted that out for us. All we've said is, by doing D is equal to S, we haven't put 0 into this memory location. Okay, so this is what I think you guys wanted to do. Okay, so you're not copying that. All you've done is you've taken D and it now points to that location. So D and S both point to the same location in memory. Alright, so we haven't effectively created a copy, we've just created two pointers pointing at the same location in memory, which is not what we want to do. Okay, so no. We actually want a copy. Alright, so we actually want to do this operation. We want to make an actual copy of the data. When you've got arrays, this is where Mem Copy comes in quite handy. So remember we've got our two variables, D and S there. So Mem Copy, first argument is the destination. Now we don't need to use the ampersand like we did up here, because remember when we declare an array, this variable is already a pointer. Right, so D is already a pointer. D, S once again is the same, it's already a pointer. Now, if I was to put the number 3 in here, alright, it makes sense, we've got 3 elements, you would only copy 1.5 numbers. Because if you were to divide this array up into the actual bytes, right, there's 2 bytes there, 2 bytes there, and 2 bytes there, because these are ints, or short integers as they are in our micro. So 3 would be wrong. Okay, 3 will only copy this byte, and this byte, and it will leave the last 3 bytes. So one of the safest ways to actually do this is to go the number of elements multiplied by the size of, which is a function built into the C language, the data type that you've saved it as. Right, so this function here, size of, returns the size of the data type in bytes. Therefore, we can multiply that by the number of elements in the array, and we will copy no matter how long or how wide our data is, 8, 16, 32, 64 bits, doesn't matter. If we want to copy 3 elements of it, sizeof will take care of working out how many bytes it is. And this doesn't just work for numerical and chars, alright, this will work for structures as well. So you could copy an entire structure by just going source structure, destination structure, and then the size of the structure data type, and it will copy the whole thing over for you in one line. You don't have to copy each of the fields one by one. So this can be really useful. Let's have another look at another example where this time we're going to be looking at copying part of an array. So this is quite common when you have char string equals hello, and there's a space there, world. Alright, and let's create our destination. I'll call it DES, and for argument's sake I'm going to say it is 10 characters long. Right, it's just got to be big enough to contain the copied memory. Right, and that's actually a really important point. Okay, if I had made our destination smaller than our source, then this byte here is going to be written into who knows what else's memory and could corrupt your whole program, and there's no error catching for that. So your destination memory must always be greater than or equal to the same size as your source, alright, or at least the number of bytes that you're copying. So just watch out for that. So big enough to contain the copied memory. And let's say for this particular example I want to just copy the word world out of the string and into my destination array. Alright, so the task is copy world from string to destination. So we can use Mem Copy to do this. Even though we're working with strings, doesn't matter, it's still just bytes as far as the processor is concerned. So remember, the first one is always the destination. It's already a pointer because it's an array. Now, this is where things get a little bit more tricky, and for just this example I'm going to show you how the string is actually made up. So each letter is, just like in a numerical array, an element within an array. In this case it's a char array. So the E, for example, is in element 1, if that was in memory. The L is in 2, second L is in 3, and so forth. So we see that the word world is actually located in memory in the elements from 7 to 11. Right? So we want that one, which is going to be 5 elements within that array. So just repeating that again, that a string is nothing more than an array. Okay, and I'll just do the beginning of the array here because I'm going to run out of room. It's a char array, and each letter is one element inside that array. Okay, and that would continue on. So the index locations are given by just like you would in a normal array. So in this case, because I want to be able to copy just that word world, I'm going to not put in string, because if I did that, it's going to start from the letter H and copy the whole thing across, or however many bytes I tell it to. Instead, I'm going to tell it that I actually want to start it copying from a particular element inside that array. So in this case, 7 is the element that contains the first letter of the word we're interested in, world. But you'll notice that this part here is no longer a pointer. As soon as I dereference it by using the square brackets here, or if I was to use a star, right, it's no longer a pointer. And remember, our mem copy requires a pointer. So the way we get around this is by now referencing the memory location. So we dereference it and say I want the character at element 7 or position 7, which will give us the W, then give me the memory address of that position. Right, so we're dereferencing and referencing in one operation. And that's where the real power of memcopy comes in, because we don't always have to say we'll start at the beginning of an array. We can copy out parts from anywhere. And then finally, the number of letters we want times the size of. Now I know a char's 1 byte, but it's good practice to keep using size of, because it does end up being more robust code. Right, so 5 times size of char, and we will now have inside our destination, if it was an array, sorry, as it is an array, after that line has been executed, in RAM we would have WORLD XXXX, as in not the letter X, but who knows what are in those memory locations. The only thing that you've got to watch out for now is that note that is not a string. Okay, memcopy does not add a null to the end of the copied array. So if you want to then treat this as, so destination, if you want to actually treat that as a string and use string length or string copy or something later on, you are going to have to manually add a null character to the end. So then you would have to do something like des square brackets. Now we've copied 5, 0, 1, 2, 3, 4. Okay, 5 characters, so position 5 would be where the null goes. So that's the last character after the end of our string, equals, with single quotes, the null character. Okay, and now it is a string. That part's optional. It's only if you're actually worried about treating it using string functions later on. In sprintf, trying to write to the LCD or do anything like that, you'll need to keep it as a string. So memcopy does not add a null to the end, alright, because it does work for any data type. Specifically because it has the input data types of void star, saying any particular data type. Alright, so to quickly summarize, memcopy is for copying memory between 2 locations. First argument is the destination memory. The second is the source memory, which will be not modified because it has that const keyword. And the final argument is the number of bytes. And I can't emphasize that enough. Bytes, not the number of elements. Alright, I showed you how we could do it with a single variable, which is not much use because we can do that quite easily. However, if we've got an array and we want to copy more than one element, right, this is where memcopy becomes very useful. Yes, we could write a for loop that did this for us, but we can do it in one line here, and it should be faster than a for loop, which is the reason why I suggest you use this. And I've showed you how, if you want to, you can copy out just part of an input array, just happened to be a string this time, didn't have to be, by indexing or dereferencing the location of the start of the character or element that you want to start copying from, and then referencing it again to provide a pointer to memcopy. Then using a size of, the number of characters, and adding a null if required. The only other thing I should say is that you'll need string.h to be able to use mem copy. Alright, so that's the library file it's contained in.